Here we have an ordinary 3-speed automatic Chrysler transmission that was used in front-wheel drive vehicles in the 1980s and 1990s. Even pretty similar to the ones they use right now. The torque converter has been removed, but this video is about how differentials work. On a Chrysler transmission, torque converter at the front like all transmissions in the bell housing. Then in this area right here is the clutches and bands and planetary gear system that make the automatic transmission work, and underneath all that is the valve body. That's the valve body. So a front drive transmission works exactly the same as a rear wheel drive transmission, except it's shorter. Once it's done doing all its thing and gears selected and being changed, the output comes here at the back of the transmission. Well, normally you would have a tailstock that tapered down and went to a drive shaft to the rear axle. Well, in front wheel drive they put 2 gears there, transfer the energy down to another shaft, and then that sends it to the differential box. On many General Motors transmissions, the valve body is here and the energy is sent right over there, and the clutches and bands and planetary gear system are here running parallel with the transmission. Those transmissions are a little bit bulkier and heavier. Well, I already made a video on how automatic transmissions work back in July of 2009, so you want to know what's inside and how it all goes together and how it changes the rotating motion into different speeds, look it up. It's called How Automatic Transmissions Work. But this video, is, like I said, is about differentials, so now we'll get to that part. So there you can see the differential part and even one of the spider gears. So basically all I've done is just remove that service access cover. One thing to note about these Chrysler trannies: if you have one that's leaking out the bottom of the bell housing, everybody would assume it would be that seal that goes on the torque converter. Well, that probably never will leak on a Chrysler. What happens on these 3- and 4-speed automatics is that there's a little tiny 1/8 inch roll pin that is pressed right through there, through a hole in that pin there, the pin that supports the spider gears. Well, for no reason at all, on higher miles vehicles that roll pin just breaks and you have no idea it happened. And as you're driving along, centrifugal force is causing this shaft to just come out. When it comes out, it doesn't quite come out far enough to hit that metal cover very often, but it comes out far enough to hit the aluminum case and housing. The part it likes to hit the most is the inside part of the bell housing, the curved part back there. So if you looked underneath, and right there, if you took your tranny off your car that had that leak, you would see a little cut here. That shaft, when it's whirling around, doesn't even make a sound. It just rubs on the inside of the bell housing and very slowly cuts a little trench. And once it starts leaking, it'll of course never get better, and the faster you go, the more it leaks. And when you park, it stops leaking because the oil level isn't anywhere near that high. So once you've got your transmission out of your vehicle, if you're repairing that problem, you just get someone to heliarc and repair the aluminum inside by welding it. Remove this bearing plate and this axle supporting bearing plate too, and this gear cluster comes out. You can weld it from the inside, you can weld it from that side, whichever you want. Put the pin back into the right position, and so it doesn't come out again, run a good bit of weld around both ends. I've never had a failure when I've done that. Then put your transmission all back together and it's all fine again. So like I said, these gears drive the final drive, which is here. So if I rotate this, that's what happens when the vehicle's not in park. Now of course this isn't a rear wheel drive differential, but if it was, there would just be 2 long smooth shafts that went through your differential housing. On a front wheel drive we have 2 axles that slide in there. And the splines on the end grip the inside of the spider gears. If this were a standard transmission, this part would be exactly the same. If you're abusing this transmission, like having one wheel locked up with good traction and the other one on ice or in the air spinning extremely fast, sometimes this gear cluster can explode. If it's a standard transmission and you're really popping the clutch hard and trying to get the one wheel peel smoking the tires around corners? Well, all the torque the splines have that are on the inside of those spider gears can cause the spider gears to split, and then of course this all explodes. When that happens, it sends so many chunks around, usually the whole transmission is destroyed. Now I've shoved one of the axles in. You can see it comes all the way through, and you can see the splines coming out. If this were a rear-wheel drive tranny, if this were a rear-wheel drive differential, it would look exactly the same, except that they have a C-clip that drops in there in a groove cut in those splines going this way, and that's what holds your drive axles into your differential housing. One on each end, of course. And in most vehicles, to get those C-clips off, you have to remove that pin, push the axle in a little bit farther, and the C-clip just drops out. Now how this works: when the transmission is moving and driving, that great big gear assembly and the pot behind it, everything is turning. Everything's turning at the same speed, so when you're driving and turning a corner, the outside wheel always has to travel a larger distance, so it spins a little bit faster. So this little gear area, and this with the spider gear, starts to spin like this, so it can give a slightly different speed to the inside axle than the outside axle. If one wheel happens to go in an area with low traction, well then it might start spinning really fast, and the other one could be barely spinning at all. The advantage to having something like that can always give an infinite ratio of speed to each wheel means that when you're turning corners and doing things with your vehicle, it's not a live axle system, like each one's not spinning exactly the same speed all the time, because that's only possible on a smooth, flat road. Under all other conditions, for whatever reason, one wheel would always want to be slightly spinning faster than the other, and then it would cause one of the wheels to always be breaking traction slightly, and then of course you can lose control on a corner and slide right out. But of course in a straight line for acceleration, something that locks up like that is actually the best. You're guaranteed one wheel won't outspin the other one. That's why they have locking differentials and posi tractions and things like that for higher performance vehicles on some four-wheel drives. One interesting note: law of physics, every action has an equal and opposite reaction. If one side of the output of the transmission differential is held back and can't turn, then this thing keeps turning, because if you're stepping on the gas and it's driving the vehicle, it causes the other axle to spin at twice the speed. So basically, it's this pin and these two smaller spider gears that are the driven ones. They're being driven by the horsepower and output of your engine, and these other ones are on the axles, and it's always putting the same amount of force on each one from there to there until something changes the speed of the wheels. Then it gives whatever RPMs are necessary to the wheel that needs them. Now I've removed the two bearing cups. I can get this cup out of here. So, that's all there is. And there's the gear that drives it, which of course goes to those gears.